No satellite can detect it. It transmits no signals, emits no heat, and produces no noise. It simply waits. Inside this cylinder, a hydroacoustic sensor captures the sound signature of a propeller. Somewhere below the Strait of Hormuz, hidden in the mud of the seabed, lies a steel cylinder about a meter long. No radar is able to identify it. It transmits no signals, emits no heat, and produces no noise. It simply waits. Inside this cylinder, a hydroacoustic sensor captures the sound signature of a propeller. But before we begin, don't forget to like and subscribe to our channel. When a vessel, any vessel, enters the activation zone, the system analyzes the signal. In less than 2 seconds, a solid-fuel rocket motor propels a 140-kilogram warhead upward, traversing the water column at about 80 meters per second, striking the hull directly from below. That is the EM-52. Designed by China and acquired by Iran, it is currently positioned under the strait through which approximately 20% of the world's crude oil passes. But the EM-52 is not the only threat in the waters. Iran maintains an arsenal estimated at between 5,000 and 6,000 naval mines, the largest in the region. These include moored, bottom-laid, drifting, and influence mines. Some naval mines cost less than $1,500, cheaper than a jet. Used ski. In 1988, a single M08 mine, a precursor to the current Iranian Sadaf-02, nearly sank the frigate USS Samuel B. Roberts. The explosion opened a rupture of up to 7.5 meters in the hull, broke the keel, and flooded critical areas. 10 sailors were injured. The repair took 13 months and cost $89.5 million. An extremely cheap weapon nearly destroyed a warship. Now imagine the impact on a supertanker carrying millions of barrels of oil. Despite possessing the world's most advanced technology for detecting and neutralizing mines, with airborne lasers, drones, and unmanned vessels, the U.S. Navy still faces a critical challenge in the Strait of Hormuz. Not due to inability, but because removal depends on multiple strategic conditions. The central problem is the very nature of these weapons. Naval mines are passive, invisible, and do not emit signals. Unlike missiles, drones, or submarines, they simply wait. They are install-and-forget weapons, and therefore extremely difficult to detect and devastating in terms of cost-benefit. An M08 contact mine costs $1,500. An Arleigh Burke-class destroyer costs $2 billion, a cost ratio of $1 million to $1.3 million. No weapon in the history of warfare offers this asymmetry. A piece of steel with an explosive charge, invented during the American Civil War, still holds the most disproportionate cost ratio in modern combat. Now consider the geography. The Strait of Hormuz is 39 kilometers wide, but the traffic separation scheme divides it into 2 navigable lanes. Approximately 3.7 kilometers for entry, 3.7 kilometers for exit, separated by a 3.7-kilometer safety zone. Approximately 11 kilometers in total. Iran doesn't need to mine the entire strait. It needs to mine a strip about 3.7 kilometers wide. And here's the final variable that makes mines uniquely dangerous. They are a safe weapon. An oil tanker hits a mine. The hull ruptures. 2 million barrels of crude oil catch fire in the shipping lane. Lloyd's of London revokes its war risk coverage for the strait. All tanker operators worldwide withdraw their ships. Hormuz doesn't close itself off by military force. It closes itself off by market forces. A mine doesn't sink a fleet. The mine sinks an insurance policy. And the strait closes not because of fire, but because of fear. And fear needs only one example. Iran has deployed 3 types of mines in the Strait of Hormuz. Each one solves a different problem. Each one requires a different solution. The first is the contact mine, the Sadaf-02, an Iranian copy of the Soviet MS-08, a steel sphere with over 100 kilograms of explosives attached to an anchor and floating just below the surface. When the hull touches its protruding spikes, the detonator is triggered. The same weapon that nearly sank the USS Samuel B. Roberts, unchanged in 40 years. No need to change. The second is the bottom influence mine. It sits on the seabed and detonates without contact. 3 sensors: a magnetometer that detects the magnetic field of a steel hull, a hydrophone that listens to the noise of the propeller, and a pressure sensor that measures the displacement caused by a passing vessel, programmable to fire only when all 3 signatures match a large ship, ignoring small vessels waiting for the high-value target: patient, selective, intelligent. The third, the EM-52 that we described, is the most dangerous. An ascending mine propelled by a rocket that rises at about 80 meters per second. No amount of armor can withstand a weapon that attacks from below at rocket speed, and there's no way to detect it until it's triggered. Contact mines that kill on contact. Influence mines that kill by signature. Ascending mines that kill by rocket propulsion. 5,000 to 6,000 of them. And all the navies in the world still remove them the old way. Divers in the water, fiberglass ships in the minefield. The United States Navy decided to build something different. Instead of sending sailors into the minefield, it designed 4 unmanned systems. Each vessel solves a step in the mine removal problem, designed to detect, hunt, deceive, and destroy mines without a single human being in the water. No other fleet possesses anything like it. Throughout most of naval history, mine clearance has been the most dangerous task for any fleet. Traditional mine sweeping requires specially constructed vessels with wooden or fiberglass hulls, because a steel hull generates the same magnetic signature that activates influence mines. Aboard these ships, bomb disposal divers don their equipment, enter the water, swim through an active minefield, locate a mine manually or with portable sonar, attach a demolition charge, swim away, and detonate it. 1 mine at a time, in waters where they can't see. Alongside a weapon designed to destroy anything that comes near, all the world's major navies still operate this way. Japan, South Korea, France, the British Royal Navy, divers in the water, fiberglass ships in the minefield, human beings solving the equation with their own bodies. The United States Navy made a decision to build a system in which no sailor would ever have to enter a minefield again. And he built 4 systems, each solving a step of the problem, capable of operating completely without a human being in the water. The system is called ALMDS, an AES-1 bar, built by Northrop Grumman and installed in a pod under an MH-60S Seahawk helicopter. The system fires pulses of laser light, LiDAR, light detection and measurement, downwards into the water. The laser penetrates the surface and reflects off objects in the water column near the surface. A striated tube receiver captures the reflected photons and processes them into a 3-dimensional map of everything below the surface, including mines. The computer processes thousands of returns per second, building a volumetric image of the water as the helicopter flies, day or night without hovering, without putting anything in the water. Think of it like a CT scan of a strait. The helicopter flies overhead and the laser maps each mine-shaped object in the water column without touching the surface. But a CT scan only shows where the problem is. It doesn't solve the problem. And there's a second problem. Laser light doesn't reach the bottom of the sea. Anchored mines are located near the surface. But what about deep-sea mines, embedded in the mud at a depth of about 12 meters? Lasers can't see them. For those, a different tool is needed. The ALMDS finds mines near the surface, but bottom mines positioned on the seabed where laser light cannot reach require sonar. The AN/AQS-20C mine hunting sonar is towed by the Common Unmanned Surface Vehicle built by Textron. The CUSV is an unmanned vessel, controlled by a single operator aboard an LCS at a safe distance. It enters the minefield autonomously, towing the sonar by a cable. In side-scan mode, it creates a wide image of the seabed. In front-view mode, it projects forward. Signal processing algorithms distinguish mines from rocks and corals by shape, size, and acoustic reflectivity. The CUSV operates continuously for 20 hours or more. No human being can maintain that level of focus. No human being is on board. The LCS never enters the minefield. Finding mines isn't enough. Influence mines, the most intelligent ones, need to be tricked to detonate. The Navy's answer is the Unmanned Influence Sweeping System. The CUSV tows a magnetic scanning cable and an acoustic generator. Together, they simulate the signature of a supertanker displacing 300,000 tons. Magnetic field, propeller noise, hull cavitation. The influence mine on the seabed detects the signal. Its three triggers align. The mine detonates, but there is no ship. Nothing above it except a cable and a sound generator towed by a robotic boat. The mine destroys itself against a non-existent target, an inverted trap. The robot induces the mine to self-destruct. Each influence mine that detonates is one less in the water. Unlike a diver, the UISS sweeps the same corridor repeatedly without risk. An ASQ-235, built by RTX, deployed from the same MH-60S Seahawk helicopter that carries the laser. For a mine that refuses to detonate against a false target, the Navy sends the Archerfish, a small disposable underwater drone, lowered by a fiber optic cable. It has sonar, a camera, and lighting. The operator in the helicopter sees real-time video. The drone flies to the mine. The camera confirms the target. The operator presses a button. A shaped charge detonates, directing the explosive energy into a concentrated jet that destroys the mine. One mine cleared. Deploy another Archerfish. Repeat. No divers, no risk. One operator, one button, 4 systems, 4 stages. Locate with laser, map with robotic sonar, detonate with acoustic decoy, destroy with precision drone. The entire mine clearance chain, from detection to destruction, can be executed without a single sailor on the water. No other navy in the world possesses all 4 capabilities integrated into a single operational package. So the technology works. The systems were built. The capability was proven. And that's where any other channel would end this video. The real question is why he hasn't done it yet. The answer involves 3 variables that most analysts completely ignore. If the technology exists, if the laser flies, the robot sweeps, the decoy detonates, and the drone destroys, then why are the mines still there? Why is Hormuz still closed? Why are 150 oil tankers anchored outside the strait, accumulating fuel costs, while the world's most advanced mine-hunting systems remain on the decks of ships that haven't yet entered the minefield? Because the Navy doesn't solve headlines. The Navy solves equations. And this equation has 3 variables that need to converge before the solution is ideal. If you remove mines while Iran is still manufacturing and launching new ones, you're mopping the floor with the tap running. You remove 100, they launch 200. The corridor never opens. The operation never ends. So the Navy turned off the tap first. Operation Epic. Fury destroyed 26 Iranian mine-laying vessels, 16 intercepted at sea, and another 10 destroyed in their ports. More than 90 Iranian naval vessels were destroyed or disabled in total. Mine storage facilities on Karg Island were obliterated on March 13th. Mine production facilities in the Iranian interior were hit by bombers. CENTCOM confirmed ongoing attacks against mine depots and manufacturing sites. The result? The mines currently at the bottom of the Strait of Hormuz are the last that Iran will ever deploy. Every mine removed is one that will never be replaced. No new mines are being produced. There are no ships to launch them. There are no deposits with reserves. The tap is turned off. The floor is ready to be cleaned. The LCS-class mine countermeasures vessels, USS Tulsa and USS Santa Barbara, carry the world's most advanced mine-hunting technology. But they don't possess significant weaponry for self-defense. An LCS in a minefield is entirely focused on sweeping. It is slow. Anti-ship missile launchers hidden in mountain tunnels, remaining fast attack craft positioned in coastal inlets, and midget submarines of the Hormuz class. Gadir operating in shallow waters. Mine clearance requires a protective bubble. Fighter jets in the air. Destroyers protecting the flanks. Marines providing close-range surface defense. This bubble has a name. It's called USS Tripoli, LHA-7, capable of carrying up to 20 F-35B stealth fighters and 2,500 Marines from the 31st Marine Expeditionary Unit. As we explained in our previous analysis, The Tripoli is the answer to the 10% problem that aircraft carriers can't solve remotely. The Tripoli has left the Western Pacific and is currently sailing at high speed towards the Middle East. Estimated arrival time, approximately 10 days. Mine removal does not begin until the protective bubble is in place, not before. This is the variable that most people ignore. The Strait of Hormuz is not completely closed. Some ships still pass, but well below average. The problem is that mines don't distinguish between targets. They threaten both foreign ships and Iran itself. As a result, Iranian exports, which are around 1.4 million barrels per day, have plummeted, since no operator accepts the risk of insurance costs exceeding the profit from the cargo. In trying to block others, Iran ended up blocking itself. Mines act as a silent economic siege. Without firing a shot, the pressure grows daily, draining revenue that will not be recovered. Removal depends not only on technical capacity, which exists with lasers, drones, robots, and sonar, but also on the ideal strategic moment. Meanwhile, the EM-52 remains at the bottom of the strait, invisible and waiting. The lesson comes from 1988. A cheap mine nearly destroyed a warship. Since then, the response has changed, neutralizing mines without exposing human lives. Today, the process involves aerial detection, robotic scanning, detonation decoys, and precise destruction. 4 steps, no sailors on the water. Ultimately, the logic is simple. Mines are cheap and effective, but limited. Each one can only fire once. And when the replenishment capacity runs out, the game is over.